This lecture will be on the second part of Chapter 12. If you remember our first section, we talked about exception handling, how we can get our program to generate errors, runtime errors, system errors, things of that nature. How do we use a try-catch exception to grab those exceptions and then manage those errors properly. That way our code just doesn't always result in something the program just stops. We give important information to the user to help them diagnose what the problem is. Not sure what's going on with my PowerPoint. I'll see if we can get back into it. Okay, so now for this section we will be talking about how to read input from and write input to, or write data to the files using the file class. There's 3 mechanisms. One is the file class itself. The second one is a print writer, and the third one you guys are familiar with, being this is your second semester in this CS 2301, 2302 Introduction to Java. It's a scanner class. But in 2301, we primarily just looked at a scanner class as an input mechanism to receive input from the user. Now, in this section, we will talk about how we can actually use it to do more things with files. Okay. So now I'm going to go over to the section where we're talking just about the files. Alright, so the file class is it's an object in Java where, similar to a scanner class that you guys have used, we can create a file object. That file object contains behaviors and properties for obtaining of files, as well as directories, and we can with the file object, we can rename and delete rename and delete the files or the directories. We cannot, and it's very important to understand this, we need another mechanism to actually write data to a file or read data from a file. The file class does not give us that the ability to do that. The file class only gives us the ability to grab a file or a folder. Here's some examples. If I wanted to grab a directory, I just say file, whatever object I want to use, I use to say f equals new file, and then the name of the folder in double quotes, which is a string. And then the second scenario is where I am grabbing the actual data file. So I put the extension after the name of the file. Now here's some reminders, and the book talks about them. And we'll probably spend more time over the course of this semester really driving this point home. You don't want to use absolute file names, and I'll show examples of that. Instead, you want to use relative file names, and these relative file names work by they're referencing files that are relative to your program, and I'll show you that in the next slide. So here's examples of absolute file names. Absolute file names mean in Windows we start with the drive, and then we're saying this is where it is on the drive. Okay, so here's 2 examples that's referencing a book.dat file. Now this is bad because let's say you're working on this program, and you require on your system the book.dat file would be one of these 2 locations. Let's say you deliver this file this program to your clients. Now let's say they don't use a C drive or a D drive. Let's say they use different letter system. You're going to find they'll have errors in their code, or your program won't work correctly because they can't find that file. What you're doing is you're requiring the user to have book.dat in this same location on their computer. And that's very difficult to do, especially if you have a wide range of clients. So relative file names are better, and here are just several examples. And this is where we say find the program relative to where or find the file relative to where the program is running. So where our .class file is, find the file relative to that. So in the first case, what we're saying is find from the PWD stands for present working directory. So this is where my current .class file is. From this current directory, go to the we call it the resource folder. Go to the resource folder and find book.dat. The second and the third example do the same thing. There's just different ways of doing it. Okay. And then in the fourth case, if you guys can see the difference, I have 2 dots there. 2 dots mean go up 1 folder and then find the res folder there and then find the book.dat file. So those are, and you can have as many the 2 dots. You can go as far as you want as long as you don't get to the top drive, top folder. But these are better ways of doing it, because what I can do now when I deliver this software, I can now also deliver that RES folder to them. So when they install my software, they'll be installing the present working directory as well as the resource folder in the exact location where I want them to install. So this gives me as a programmer more control over my code, and I can guarantee when that program works, it can find the book.dat file. Okay? So any questions to that? All right, so here is how we write data to a file. This is using the print writer class. And you guys can see in the example inside the try, I'm doing a combined print writer with the file instantiation. So I create a print writer object, but the print writer object requires a file object. And instead of creating a separate file object and passing it as a parameter to the print writer, I just do it all in one line, because in this case I don't need the file object. And then once I have the print writer object created, I can use a print or a .print or a .println to print things to the file. And when we do a print writer, we're required to use a try, because it's going to throw an exception. If it can't find something, if it can't write something to that file, it's going to throw an exception. So we need to surround this in a try catch. And then it's always a good habit to write a finally. We mentioned finally in our last lecture. This is where this always happens regardless if we get an error. All right, so if this executes, if everything in the try executes well, we go to the finally. If everything in the catch, or let's say this guy doesn't, the try block doesn't execute everything, it goes to the catch, but we still need to close that print writer object. And we close that print. If we don't close that print writer object, guess what? That file doesn't exist. So let's say I'm trying to print data to a file. I do everything right, but I don't close that. I end my program and I don't close the print writer object. That file won't exist. Okay, so you have to make sure you're closing the print writer object before your program executes and terminates. Scanner class. So we're going to use a scanner class to read data from a file. Very similar to if you want to read input from a user. It works in the same way. In this case, we need to have this surrounded by a try block, just in case the file doesn't exist or we don't have access to reading from the file. And we can do the similar setup where we do an input.hasNext. That way we can read the entire file. And then if we know the structure of the file, we can just say grab the data. If we know it to be all integer values, we can grab it as ints using the next int. If we do not know the actual content of the file, can you guys tell me how would I grab that data? I'm sorry? Right, we're going to do a .next because we can grab it as a string, and then we can always go from a string to anything we want. We can go from a string to a double to an int, and we can surround those conversions to tries as well. So in most cases, now again definitely for this chapter, you're going to know the contents of the file. But as we move forward, you may not necessarily know the contents of the file. So it's always safer to just grab it as a .next, store it into a string, and then do whatever conversion you need to do on that string to store it into whatever data primitives you need. All right? So are there any questions to that? No questions? We'll move forward. As a matter of fact, I'm going to end this lecture now, and then we'll start with a lab assignment. So we'll end it now, and then I'll have a couple more videos on some problems in the book.